As you move deeper into cloud native development, you will find that containers have become the go-to way to package, deploy, and run applications. And for good reason. They're fast, portable, and resource efficient. Now, when you're working in Microsoft Azure and want to run a container without dealing with the complexity of virtual machines or full orchestrators like Kubernetes, Azure Container Instances is your best friend. Azure Container Instances is the fastest and simplest way to run containers in Azure. You don't need to manage virtual machines, clusters, or any infrastructure. All you do is define your container and let Azure handle the rest. This makes ACI an ideal choice when you need to quickly spin up containers for isolated workloads, development environments, testing scenarios, or even production microservices that don't need orchestration. Before you can run a container in ACI, you need a container image. Think of it as a portable box that contains everything your app needs to run. When you create a container image, it includes your app code, the runtime environment like Node.js, Python, .NET, system tools and libraries, and configuration settings. This container image becomes a fully self-contained executable unit that can run reliably across environments, whether on your laptop, in Azure, or inside a Kubernetes cluster. One of the biggest advantages of using Azure Container Instances is how quickly you can get up and running. You can launch containers in just seconds without waiting for a virtual machine to boot or a cluster to scale. When you need your application exposed to the internet, ACI makes it simple by letting you assign a public IP address and a fully qualified domain name. So your container is instantly reachable. You also have full control over resource allocation. You decide how much CPU and memory your container needs, and you only pay for what you use. For scenarios where persistent data is required, ACI supports direct mounting of Azure files, allowing your container to maintain state across restarts. Whether you're deploying a Linux-based app or something that runs on Windows, ACI supports both OS types. Just pick the one you need when setting up your container group. You can even run multiple containers side by side in a single container group, allowing them to share resources and communicate through localhost, which is great for multi-tier or composite applications. And if your app needs to stay secure and connect privately with other Azure services, you can deploy your containers into an Azure virtual network, giving you both isolation and controlled access. You should use ACI when you want to deploy containers fast without the overhead of managing infrastructure. It's especially useful for running stateless web apps, APIs, or background jobs, hosting development and test environments, creating event-driven, short-lived workloads, and integrating into DevOps pipelines for build test phases. Running apps that don't need orchestration but still need to be deployed in the cloud. So, what's your key takeaways? With Azure Container Instances, you are unlocking the power of containers with minimal friction. You get speed, simplicity, and scalability without the heavy lifting. Whether you're just starting your container journey or need a quick solution for isolated workloads, ACI gives you a flexible and cost-effective platform to get up and running in seconds. Now, let's get into the Azure portal and create Azure Container Instance. You can get to the Azure Container Instance service just by typing the container instances in the Azure search bar as shown. To get started, simply click on the Create button at the top or in the middle of the screen. You are currently on the Basics tab, which is where you define all the essential settings to get your container up and running. First, you start by selecting the subscription under which the container instance will be created. Then you pick or create a resource group. Next, you define your container name, which will be the unique identifier for this instance. You then choose the region where your container should run. In this case, it's set to Australia East. So you are deploying it close to your users or other Azure resources in that region. If needed, you can specify availability zones, but that's optional and left as none here. For the SKU, you are using the standard tier, which is available in all regions and provides a good balance of performance and cost. You then specify the image source. Here, you have options like a quick start image, Azure Container Registry, or any other public-private registry. In this example, you are using an image from a public registry, mcr.microsoft.com/aci-hello-world:latest, which is a simple demo container. Right below that, you can adjust the size of your container instance. It's currently configured to use 1 vCPU and 1.5 gigabytes of memory with no GPU assigned. You also have the option to run the container on Azure Spot instances for cost savings, though it's disabled for this region. This page makes it incredibly easy for you to spin up a container in Azure without dealing with infrastructure. Just fill in the form, and you're moments away from a running container. Once you've configured all of these options, you can proceed to the networking tab by clicking Next. You are now on the networking tab of the Azure Container Instance Creation process, and this is where you define how your container will be accessed over the network. First, you choose the networking type. You have three options: public, private, or none. If you select public, Azure assigns a public IP address to your container instance, making it accessible directly from the internet. If you choose private, your container will be deployed into a virtual network, which gives you more control and security. Selecting none means your container won't have a network endpoint, which is useful for background jobs or internal only processing. Next, you define the DNS name label, which becomes part of the fully qualified domain name for your container. For example, if you set it to myKey, your container might be reachable at something like mykey.australiaeast.azurecontainer.io. Right below that, you set the DNS name label scope reuse. This controls how Azure allows reuse of DNS labels across scopes such as tenant, subscription, or resource group. Choosing tenant ensures that your DNS label is unique across your entire Enter ID tenant, which reduces the chance of conflict. Lastly, you specify the ports you want to open. In this case, it's port 80, which is commonly used for HTTP traffic. This means your containerized application will listen for web traffic on that port. Once you've set up these values, you're ready to continue by clicking Next. You're now on the Monitoring tab, and this is where you configure log collection and diagnostics for your container. Here, you have the option to enable container instance logs by simply checking the box. When you enable this, Azure will collect runtime logs from your container so you can monitor its behavior and troubleshoot issues more effectively. Below that, you need to choose the subscription where your monitoring data will be stored and then select a log analytics workspace. This workspace is where all the logs from your container instance will be sent, so you can query them later using Custo query language, visualize trends, and set up alerts if needed. If you don't already have a workspace, Azure lets you create a new one right from this screen. Setting this up is highly recommended because it gives you full visibility into your container's performance and behavior without any manual instrumentation. Once you're ready, you can move forward by clicking Next. You're now on the Advanced tab, and this is where you configure additional container properties and runtime behavior. First, you choose the restart policy, which controls what Azure should do if your container stops. You can set it to restart always, on failure, never, or let it restart only when something goes wrong. This gives you flexibility depending on whether you are running background jobs, web services, or one-time tasks. Next, you can define environment variables for your container. These are key value pairs that your application can use at runtime. You also have the option to mark any variable as secure, which ensures that sensitive values like passwords or tokens are encrypted and hidden in logs. If your container needs to run a different startup command than what's defined in the image, you can use the command override field. Here, you can specify a custom command and arguments using the syntax shown in the example, giving you full control over what runs when the container starts. Finally, you set your key management preference. By default, Microsoft Managed Keys handle encryption for your container resources. If you require tighter control, you can choose Customer Managed Keys, but this option requires additional setup, including assigning permissions through a service principal. Once you've adjusted these advanced settings to fit your use case, you are ready to continue by clicking Next, or you can jump to Review, plus Create to finalize the deployment. Confirmation screen appears before kicking off the real deployment. Just go ahead and hit Create, and ACI will be up and running with your chosen container. After successful deployment, just open up the Azure container instance as shown and copy that FQDN link in the browser. And there you go. Sample container from Microsoft registry that you chose is up and running.